Okay, so this is question number 193 on A3. So A3, number 193. Okay, so the question's asking here is we've got the polynomial x squared plus bx minus 15. And we're asked to find for what values of b does this factor. So basically, if you think about what's going on here, if we go to factor this, we're going to get an x there, an x there. My factors of 15 are 1 and 15, 3 and 5. Now, since the leading coefficient here is 1, I do not need to write the factors going the other direction. So I don't need the 5 and the 3. So basically, I just need to see what's possible for these to differ. So possible differences here, the difference between these two is plus or minus 14. And the possibility here is plus or minus 2. So those are your two answers. B could be plus or minus 14, or B could be plus or minus 2. Okay? Okay, very similar. This is A3, number 195. Okay, we've got x squared plus bx minus 12. We want to factor this thing and find out the possible values for b. So once again, we're going to write down our factors of 1 and of 12, 1 and 12, 2 and 6, 3 and 4. Because this is negative, we're looking for those differences. So the differences here will be plus or minus 11, plus or minus 4, and plus or minus 1. So we've got 6 different values total for that one. Oh, okay.
Here's this for you.
Okay.
And I'm having a problem with my equation for some reason, which I'll have to figure out later.
Does that include all the comments on the slides too, or not?
No, the slides are the first batch I gave you.
First batch you gave, which is where?
No, it's not in your seat. They aren't getting it to you.
Oh, okay.
That's comments on your comments.
Okay.
You want to go take care of it? You're welcome to. Let's go.
Go on. Go on. Okay, so this is the deal with problem 209. We start with a piece of paper, a standard rectangular piece of paper. We're going to cut a certain amount out of the corners. Okay, having cut a square of length x out of each of the corners, we can then fold up those corners and create a box.
And there is our box. That illustrates the construction we're doing in this problem.
Okay, this is number 205 on A3. Now, you've just watched the video to show how these things fold up. So essentially, we've got a rectangular piece of material. We're cutting squares out of the bottom like so, and we're folding it up. Now, if you look at the dimensions, each of these things is X. The entire box here is 18 centimeters. So this little piece right here, which is the bottom, is 18 minus 2x. Okay, likewise, this whole box right here is 26 centimeters. So the piece that we're interested in, which forms the bottom, is 26 minus 2x. So that gives us an equation for the volume of the box. V is going to equal x, which is the height, remember we're folding up x here, times 26 minus 2x times 18 minus 2x. Okay, and let's see, that was the first question. Okay, for part B, so this is A, for part B, we're asked to find out the volume of the box when x is 1, when x is 2, and when x is 3. We're simply going to plug those values in. We're going to get 1 times 24 times 18. And as soon as I get my calculator here, sorry about that. So that is going to be 24 times 18, which is 432. So this one is 432. When x is 2, we're going to get 2 times 22, 26 minus 4, times 18 minus 4 is 14, which is equal to 2 times 22 times 14, which is 616. And then lastly, we're going to put 3 in for x. So this is 3 times 20, and 18 is 12. So we get 60 times 12 is 720. And actually in calculus, you'll find out how to actually maximize the volume of the box. But that's beyond what we're doing right now. That was all was asked on that problem. Okay, number 229 on A3. We're asked to factor x to the 2n minus y to the 2n. And the key thing here is to realize, again, using laws of exponents, this is x to the n squared minus y to the n squared, which is the difference of two squares, which is going to be x to the n minus y to the n times x to the n plus y to the n.